For inverse matrices, we are going to find these purely using our calculator. Okay, now there is a way to do this by hand. I'm not going to go through and show you that. It requires finding the determinant, which actually is a pretty easy equation, but there's a little bit more work to it, so we're just going to use the calculator. All right, what's that?
You learned it last year?
I don't know. All right, so here's a couple things we need to know. Two matrices are inverses when if you multiply them, you would get your identity matrix. Okay, so we just talked about identity matrix. So it'd be the same as 1/5 times 5 versus 5 times 1/5. We know those are inverses because they multiply to 1. Matrices work the same way. If you multiply two square matrices and they equal the inverse matrix, then you know that they're inverses. Okay, so these two are new definitions. A non-singular matrix has an inverse, and a singular matrix does not have an inverse. Okay. So to find an inverse, we're going to do this together here. Everybody go and type this into matrix A. Okay, we just want to find A inverse. So we're going to go to A, and we press the inverse button. This time we're not going to press second. We're just going to press X inverse. Done.
Wait, what?
X inverse. So instead of second X inverse, you're just going to type in A, and then you're just going to press X inverse.
I remember this.
So then this becomes 1, -1, -2, 3, and then you're done. That's the inverse. Easy peasy. All right, so we have this guy. So I'm gonna put it into A again. All right. Now when we do this, what happens? Yeah, what kind of error? Singular matrix. And remember, a singular matrix is a matrix with no inverse. So this is a singular matrix, which means there is no inverse. Okay? I would take either one of these answers. And then the last one, I'm going to retype this into A. And then we have an answer, so we just write that out. All right, any questions about finding the inverse? Not so bad, right? Okay, so the reason why we want to find the inverse is we learned how to solve systems using that row reduced echelon form, but there is also a way to do it using inverses. So what I want to talk about is this equation right here. And we have 6x plus 17y equals 16 and 3x plus 9y equals 2. Okay, well, the way I could write this using matrices is to use the the coefficient matrix. So I would get 6, 17, 3, 9 times the variable matrix, which is xy, equals the constant matrix, which is 16, 2. And these are all assigned names. This is A, this is X, and this is B. Is everybody okay with that? A, X, and B. Okay. Now, just so you guys know, if I multiplied A times X, so remember we did the rows times the columns. If I did that, I would get this system here. Like it would look just like this, just so you know. All right. So next, when we have this, our goal is to figure out what X and Y are, right? The thing about multiplication with matrices is it is not commutative. Right? So I need to get rid of this A, and the way to get rid of that is to multiply by the inverse, right? Well, I need to multiply by the inverse in front of this. So I would have to put A inverse here, because if I put A inverse after the X, right, then that's not going to eliminate this. But what do I know about A inverse times A? What does that equal? Yeah, equals your ones, your identity matrix, right? And your identity matrix times any matrix is itself. So this becomes I, right? And then we still have X equals, now I put this in front of this product, right? And position matters when you're multiplying. If this is going to be equals, where do I have to put the A inverse on this side? In the front of the B. So it has to be the same position. It has to start with A inverse B. So what happens is, then we end up having X equals A inverse B. So if I find this, then I'm going to find my X and Y, and all I have to do from there is write it as an ordered pair. Okay, now what you guys need to know, I know this has this set up, but I'm going to change it a little bit based on what you guys need to know for your quiz and for your test. All right, it is actually going to prompt you for the coefficient matrix. And then it's going to ask for the inverse matrix. And it's going to ask for the solution. All right, so this is what you're going to have to do on the test and the quiz. Okay, so what is our coefficient matrix here? 6, 17, 3, 9. And then to find the inverse matrix, we got to plug that into our calculators. All right, and we get this. You guys will not be able to leave your answer like this. Guess what you're going to have to do? Yes. So we get 3, negative 17 thirds, negative 1, 2. Okay. And then it wants a solution. However, we don't have enough for the solution. Here's what I have so far. I have A, and I have A inverse, right? But I am looking for the solution. I need X equals A inverse B. So which matrix am I missing right now to get the answer? If I want to find X, I have the A inverse here. We're missing B, all right? So this is the part that you would do on your own. So it's not going to prompt you for this on the quiz. So what is B? 16, 2. Okay, B is 16, 2. So at this point, it only wants a solution. I would go ahead and go back to your matrix, type in B. B is a 2 by 1. So 16 and 2. And then type A inverse and go back and put in B. A inverse B. And that's going to be your solution. Ugh, grr, Mrs. Weber. Does work. Did I type it into A on accident? I did. You see what I did? I typed in my B into my A, you guys. And nobody said anything. You're like, yeah, Mrs. Weber, that's good. There is a solution. B. There we go. Grr. All right, ready? All right, what do we have to do from here, though? Math, frac. So here's the thing. This is not our solution, you guys. Do not give me a matrix for the solution. What would be the appropriate solution for a system of ordered pair? So we get 110 over 3, comma, negative 12. So be careful for that. Make sure you write it in the appropriate format, an ordered pair, an ordered triple, whatever you need to do. All right, everybody try this guy here. All right, so what I want you guys to find is, I want you to find the coefficient matrix. I'm going to put this down here. So find the coefficient, the inverse, and the solution.
oh